So let's evaluate the pH at a couple of different points here. We saw that the pH originally, because this was a strong acid, is just negative log of 0.1, which is 1. I guess 1 with 3 zeros because we had 3 to begin with. So that's our original pH. What about after we've added 30 mLs of NaOH? Let's see what we can do there. If we've added 30 mLs of NaOH, let's look at our original moles of acid and base. We're going to do the same type of calculation that we did for the buffers, except we're just going to have to do ice tables and all that. This, because they're strong, we can just do the log directly. So we have our NaOH added. So really we've got, originally speaking, we had 0.1 molar and 50 mLs of HCl. That means that we had 0.005 moles of HCl. That's 30 mLs of the NaOH. It's the same concentration, will be 0.00300. So we have 0.00200 moles of HCl left. We're going to ignore the water that's created as part of this reaction. That's just going to make things more complicated. And let's just say our total volume is 80 mLs, because that would be the 30 mLs plus our 50 mLs. So we have our new concentration, which will be 0.002 divided by 0.08. Remember to put that into liters. And so our new concentration will be 0.025. And so if we do the negative log of that, negative log of our answer, we get pH is 1.60. So even adding, we'll need some sig figs here perhaps. Even adding all of this base, so adding more than half of the base, our pH is still quite low, 1.6, very, very low. So we see here in our graph that we are expecting it to stay very low for a long time until we reach close to the equivalence point. Let's evaluate it when we've added 49 mLs. If we do that, we can kind of cheese it because we've already seen some of this math before. 490. You get 0.00010. And now our total volume is going to be 99 milliliters. So if we do this math, 0.0001 divided by 0.099, we get 0.001. And if we go ahead and negative log of this, oops, not second, there we go. The pH here is 2.99. We'll just say 3. So even really, really close, we're still only at 3. If we look at 49.9, at that point, we'll start seeing some drastic things change. Here, we could just do it. At 49.9 ml, we'll have, let's see, 0.12341. Sorry, 4 zeros and then a 1 divided by 0.0999. We get 1 times 10 to the negative 4. If we negative log of our answer, negative log of our answer, we get pH of 4. So again, it's very, very close that we start seeing these very drastic changes. So we saw all of this. We've added 30, we've only increased our pH by 0.6. We had 49, we've only increased our pH by 2. But we add 0.9 more, we increase our pH by 1. So very, very drastic changes as we approach the equivalence point. And so with these, thankfully with the strong acid, strong base, we don't have to worry about the ice tables as we will with the weak acids and weak bases. And so in our next video, we're going to take a look at what to do for that.